Okay, so I'm going to do a few, first of all, introduce myself. I'm Bryce, VP of Products here at Univa, and I'm going to give you some background on NAVOPS launch and Univa Grid Engine to explain how the two systems work together, and then I'll demonstrate actually doing some bursting in the cloud. So first of all, what is NAVOPS launch? It really is something that came out of necessity within Univa. So we had to, test our environment, our software. We had to test Grid Engine at a much larger scale than we could possibly have on-premise. As you saw, we created that million-core cluster, and in fact, that cluster was built using NAVOPS launch. So that's really what was the fundamental idea that made us move in this direction. But then we realized, our customers can use it, and other people can use it, and you can use it to build all different types of clusters, whether they're physical, virtual, on Amazon EC2, and even on other types of clouds or multi-clouds as well. And then as time went on, we also realized that you need some sort of automation, some sort of policy in there, very much like if this, then that. If something happens in the environment, do something. Create a node, move things around, that type of thing. And so with all that put together, that's really what NAVOPS launch is. And as I just mentioned, it really does focus on that, being able to define really automation rules to say, take metrics or data within Grid Engine itself and then make a decision. And that part was important to us because many of these other types of systems typically rely on the data that comes from the infrastructure. So they look at, CPUs, or they look at, utilization or something like that. But, the customers are more interested in, the application itself. How many copies of this application are waiting in the queues? Who submitted it? Which project was it? Who's more important than the other guy? Those are types of decisions that they want to make, not just low-level decisions. And you can do that with the automation in NAVOPS launch. So a system that can go and connect to different cloud providers and create instances on demand, and then a automation system on top of that drives the whole thing, allows us to get to this idea of a seamless hybrid cloud where many of our customers want to go. Now, of course, there are other things that they need to make decisions on in order to get there. You can sort of see that from the diagram. I mean, we can definitely do the Grid Engine part, we can definitely do the automation in here on launch, but we can also talk to them about what types of decisions they have to make on the data management, because unlike, creating a cluster completely in the cloud, if you are doing this hybrid environment, you have to have some sort of data management. Is it going to be, a NetApp on tap? Is it going to be an Elastifile? Is it going to be something even as trivial as rsync, which actually some of our customers do, to move that data from their on-premise into the cloud environment. The other part that we do is really seamless to them. We create the nodes, we add them to the Grid Engine cluster, we set everything up so you can just run that work. And it looks like it's running locally. From the user point of view, they don't really care. Okay. One other really important thing before I move on is this whole VPN, VPC environment. I mean, Ian alluded to this when he talked about security. I mean, we spent a lot of effort and time making sure we understand that. And, people do have to know that to get real performance out of it, you do have to have that sort of like IPsec tunnel, that nice secure environment between your on-premise networks and, say, Amazon EC2. I mean, you could do it with software and VPNs, but frankly, they don't work that well as time goes on and things scale. Okay, so I think we're getting to the demonstration part now. Here's the part. I'm going to have to get my mic holder. All right. So I did talk a lot about all the components in NAVOPS launch, but first of all, my eyes are going bad, sorry. So what you see here is the front-end UI part of the system, and in here, I think the job is actually still running. In here, It's showing you the status of jobs in the system. In this case, I do have a TensorFlow job that is running. It's probably been running for quite a while. And there are other things in here that can give you information, general information on the cluster, such as the utilization of the cluster, what the cluster queues are doing, things like that. How many nodes are in the cluster, and in this case, there's only 2 really fat nodes. This one here is the master. It's not really doing anything. And then, as I mentioned, there is the automation part over here. And this is where you sort of make the decision. Typically an administrator would do this. And they'd set up and say, okay, I'm looking for jobs that are pending, and there's really no nodes to run in the cluster. And pretty straightforward. You just have conditions where you can say, I'm looking for jobs that are queued. That's what this QW means. And I'm looking for jobs that are submitted with a particular resource. In this case, the resource I chose was burst. And you could create your own. You could say, I want it to be widgets, or I want it to be a particular metric of my own that I define that tells me when it should burst. And you, of course, can save variables, which allows you to perform actions. So in the case of this is I want to know how many slots or how many cores I need to add to my cluster in order to burst properly. That's what this is doing. So it's capturing the number of slots that the job would need. And then it performs an action where it calls out to NAVOPS launch and says, add a bunch of nodes. And in this case, didn't find any because the jobs are running. Similarly, when things are done, there's a cleanup rule, which looks for, the host is not running any jobs and the host is not in an error state. Then clean it up and delete it. So this part is all sort of set up once. And once it is, people just either use the tools that they're typically familiar with, or use the qsub command line. In this case, I've got 2. I got a really long running job here, so I'm going to delete it. You can see 90. And we'll submit it again. Just to get the system to, instead of us waiting here and watching the thing start its automation, which will take about 30 seconds or so, I'm going to force it to run. Oh, this one's disabled, so hold on, let me fix that. Enable it. All right. Let me manually delete them because it'd be easier to show you that way. Oh, actually, it already deleted them, so I was too slow. So the automation actually did run. I guess I must have triggered it while I was turning it on. And while I did have 2 additional hosts in the cluster, you just saw they disappeared. Or maybe you didn't see that. Up here, they were here. You can see 234 and 33. And then after I turned on that rule, it went and realized that it doesn't need them anymore. There's no jobs, so it deleted them. So let's submit another job. And instead of me typing it all, because it could take a while, I'll just copy it from here. So what this job was is it was a TensorFlow job. I asked for 16 slots, so 16 cores, and I told it I wanted to burst. So basically just an indicator so that, please run this somewhere on the cloud. And then I gave it the usual path and the submit script, and then the port it needs to run on, and then the actual example pi. This is just an example TensorFlow. And if you look here, you'll see it's queued and waiting. Of course, if you prefer not to look at, command line, you can see here it's also queued and waiting. And the reason it's waiting is because there's no machines to run it. So what should happen now is if we stand here and I talk enough, the system will trigger and then actually add a couple of nodes, and then once they come up in Amazon, they'll automatically join the cluster, and then they'll be ready to run, and then the job will be dispatched to it. Again, that's all done by the rules. So you can see, using this type of system, I can take any sort of data and metric in here. I can, do my conditions based on anything in Grid Engine. It could be, the priority. It could be the department the person submitted their job from. It could be the job name. It could be the project they belong to. And I can make a decision on what to do. That's the really interesting part about it. And let me see if it actually triggered here. It looked like it may have. Yep, it did. There's job 91. So it realized job 91 can't run. It's adding the nodes right now. See, these two nodes.
Quick question.
Yep.
One of the tricks with Amazon, if you're using things like Red Hat, is you pay by the hour, not the second. Is there a business rule you could add that says, if this node has been running for 2 minutes, don't shut it down, reuse it?
Yeah, in fact, some of our customers do that. I mean, I'm in the demo, I've made it really aggressive, but I could make it so that it checks to see how long it's been up and then don't delete it, right? Yeah.
Question. Put your list of criteria that you can use for the decision engine. Is there the opportunity to create customer criteria as well based on that?
Absolutely, and that burst one was a custom one. So over here, Grid Engine allows you to extend the system with any kind of complex or metric that you define, and they can be, you can have them managed and counted by Grid Engine, or you can have like an external collector where you collect it and then tell Grid Engine what the values are.
And can this be changed? Can you change decisions? So I change criteria while going on to further specific criteria.
Yep, you can chain the rules together. So when I had rules here and it says the action in the rule, I can say execute another rule, right? So with the output of that rule feeds into the second rule, and then they can chain together. It's pretty simple. It's really if this, then that, is what it is.
So the immediate question pops up. Can you specify spot and reserved instances? How do you get accounting back to the user level?
So the accounting is tracked by Grid Engine the way it is always tracked in the system. So the user does what they always did, which is a QAct, and then on the job.
Right, but does QAct know it spawned a reserved instance which cost 5 times what it would cost if it was a spot instance?
QAct doesn't know that, no.
Yeah,
I'd have to
so
add addition.
There's a whole extra level of accounting that appears to be ignored and assumes central cost absorption.
When you say, there's different ways we can slice the cost. I mean, we can set it up by account, right? Which is what typical.
Well, we currently have project-based
Yeah.
accounting.
Mm-hmm.
But if a project might partially spin up Amazon resource,
Yes.
that's extra cost.
Right, so I could add, when we had that extra resource, the burst tag, I could add another tag to indicate that that was an Amazon, say, spot instance or an Amazon on-demand instance. And then you can do the QAct based on the filtering on that, and it'll show you.
There is a whole level of complexity because
Yeah.
our semiconductor business unit will want to spawn off maybe fat nodes and
Yep.
others would want just very basic instances.
Yes, and that can be handled in here by setting, I didn't show you that level of detail, but within the configuration, you can define, basically different profiles for it to launch. And so when you're triggering that rule to say, go create something, I would create a rule based on, say, I need detect the jobs that require, say, 16 cores, right? And then create an instance of this size to manage that. So you want to be able to, you can create rules that map the memory and core requirement of the job to the instance size. You can match that so that it will only create an instance big enough to run that job, or instances, right?
Still doesn't resolve my
the accounting.
cost allocation to the business.
Yeah, I mean, I think that if we worked with you and discussed, we could probably add additional functionality into this tool here to collect the data, because in this version, I can't show you, but because this is the previous version, but the latest version allows me to take the data from Grid Engine and the accounting from Grid Engine and also pull in data from another third-party source, right, like Amazon, and then combine the two. And with some work on our engineering team, we could combine that data to create a consolidated report.
Yeah. Okay.
That would help, but it is some work, I agree.
It's a lot of extra work, yeah.
But if we do it once, then you just have to go in here and run the report, and then it's there all the time.
Can you support multi-cloud?
Yes. I mean, this is an Amazon here. I can support Amazon, Google, Azure, OpenStack.
And so can you build a rule to move jump from cloud to cloud?
You could do that as well, yes. There's nothing stopping you from doing it. I mean, you'd have to think of a good reason to do that, right? Yeah. You could create a rule that looks at the price across and then send it to the right one. Things like that. Did it clean up here? Let's check. Well, actually, the nodes are online, and the job is running. This one takes a long time to run, so I'm not going to run it to the end.
I have 2 instances being created as a job just consumes 1.
It didn't. It was 16 slots. See?
Oh, yeah, okay.
So it created 2.
That's
Yeah, it's an MPI job. Okay, that's probably a good overall description. Do you guys have, well, let's see. Probably
We're
any
over to the
questions-
panel
any
discussion now.
Questions on this before we go? Yeah.
Over there?
How do you handle GPUs in that environment? How much information can I get back from the Amazon that's maybe requesting to those VMs? Because what I am interested in, how efficiently are people using the GPUs so they don't spawn off on an expensive node and then use it for only 20% utilization.
Yeah.
Are those numbers available in one or the other way?
So we get, I mean, right now, Univa Grid Engine has basic numbers out of the NVIDIA GPUs, but we also, as you saw, Duncan mentioned DCGM. We're integrated with that in the next version, which is out in about a week. And then I'll get more detailed information metrics out of the GPU. I'm not 100% sure if it gives me the type of utilization that you want, though.